I'd like to go over linear functions today. We'll look at the standard form of a line as well as the slope-intercept form of a line. A linear function is of the form y equals mx plus b. You can also write it in function notation, as they did here, as f of x equals ax plus b, and for some reason they used a instead of the m that we're all familiar with. From previous classes, you probably remember that m is the slope and b is the y-intercept. So in this example, you are graphing the line f of x equals negative 2x plus 6. What the writers do here is find the x-intercept and the y-intercept, and then connect the dots. The x-intercept is the point where the line crosses the x-axis. In other words, the point whose y value is 0. So by substituting 0 in for y and solving for x, they found the x-intercept is 3. The y-intercept is the point on the line that crosses the y-axis. In other words, the point where the x value is 0. You can see that when 0 is substituted in for x, f of x, or y, is equal to 6. Now you know the points 3, 0 and 0, 6 are 2 points on the line. So plot those 2 points, connect the dots, and voila, you have your line. What you probably remember from previous classes is that we can plot the point on the y-intercept, or we can plot the y-intercept on the graph, and then use the slope to find some other points. We just have to remember that slope is described as rise over run. In this case, the y-intercept is 6. The slope is negative 2, which as a rise over run value would be negative 2 over 1. So a rise of negative 2, or down 2, and a run of 1, or go right 1. So if we start at 6 and go down 2 to the right 1, then we find however many points we want to connect the dots and draw our line. Now, domain describes all the x values that can be substituted into the equation, and range describes all the y values that can be substituted into the equation. So if we go back, we can see the domain and the range are both negative infinity to positive infinity. If we look at the equation, there's no values of x that I'm prohibited from using. I can plug any number I want into that equation for x. So I can think of my domain as any number I want, or negative infinity to positive infinity. I can also look at the graph. If I want to draw, say, lines where the blue line ends, where my line ends, so I can show the stopping point, or maybe I can show the starting point of the line, that's another way I can figure out domains and ranges. However, on this line, there is no starting or ending point, which is another indication that the domain and the range are all real numbers. And of course, the all real numbers version of in interval notation would be from negative infinity to positive infinity. Here is an example where we're going to graph a horizontal line. So we have the line f of x equals negative 3. Remember, that's the same as y equals negative 3. And then we're going to give the domain and the range. So think of this as the equation saying that y always equals negative 3. X can be any number you want, but the y coordinate is always 3. What that also means is that y can never be 0, which means it's never going to cross the x-axis. And what they point out here is that a line with no x-intercept, which it won't have, is parallel to the x-axis, which is how you know it's a horizontal line. Well, this means that the x values can be anything we want. Therefore, our domain is negative infinity to positive infinity. Our range, our y values, are only the number negative 3, which is why it says here the range is negative 3. Now here's a graph of x equals -3. Again, we think of that as x, all of the x values on all of the points on this line are equal to -3, which means x is only -3 and therefore can never be 0. So it's not going to ever cross the y-axis. So it's parallel to the y-axis, which makes it a vertical line. Now, if we want to talk about the domain and range of this line, our domain is very restricted. The only value that our domain has in it is -3. On the other hand, our range is going to be any values of y that we could possibly think up, which is any real number. So our range is -infinity to +infinity. Here is an example of where we want to graph the line 4x minus 5y equals 0, and we'll be given the domain and the range. This line is what's called in standard form versus slope-intercept form. So for example, y equals mx plus b. So you could solve this for y, and I imagine that quite a few of you would prefer to do that. But there is another way to do that, and that's by finding intercepts. When you have a line in standard form, finding intercepts is relatively easy. So what we're going to do is find the y-intercept first, and in order to do that, that's going to mean we're going to plug 0 in for x. And what we have is the equation then -5y equals 0, which turns into y equals 0. So when x is 0, y is 0. Now, if we find the y-intercept, we're going to find the same thing because we just said when x is 0, y is 0. But in terms of how to find an x-intercept and a y-intercept, this is how you do it. To find the y-intercept, let x equal 0. To find the x-intercept, let y equal 0. In any case, for this particular equation, this graph has one intercept and it's at the origin. So both the x and the y-intercept are at the spot 0, 0. So in this case, we're going to need to find a second point. So what we're going to do is choose any value of x and substitute it into the equation. Now they chose to substitute 5 in for x, and then they solved for y, which turned out to be 4. So the point 5, 4 is a second point on the line 4x minus 5y equals 0. So once they have the 2 points, 0, 0, and 5, 4, they connect the dots. Now it does ask us to give the domain and the range. Notice there's no ending point on either end, on the right side of the graph, on the left side of the graph, on the top of the graph, or the bottom of the graph. That's an indication that we can use any x we want. We can use any y we want. So perhaps you would have said in previous classes, the domain is all real numbers and the range is all real numbers, but we're going to use the term negative to positive infinity. Here they just go over what slope is. So what we're looking at is the difference of the y values compared to the difference of the x values. So you should be familiar with this equation from other classes. That triangle in front of the y and in front of the x is not really a triangle. That's the Greek letter delta. So you could read that as delta y over delta x. It just means change in. The change in the y's divided by the change in the x's. And here they're just reminding you that it really doesn't matter if you write it as y2 minus y1 or if you write it as y1 minus y2. What's important is that if you start with y2 in the top, you have to start with x2 in the bottom, and vice versa. If you start with y1 in the top, you must start with x1 in the bottom. The slope of a vertical line is undefined. And here's an example of that. So we've got these 2 points. This is a pretty straightforward example of using the formula. So you're just going to plug stuff in. So the difference of the y's, that's what that delta y means, is -11. The difference of the x's, that's what the delta x means, is +6. So our slope is negative 11 over 6. How about this example? The difference of our y's over the difference of our x's. So the difference of our y's, you see, is negative 11. The difference of our x's is 0. So what you notice is that when you calculate this, you get a 0 in the denominator. So our numeric value is undefined, which translates into our slope being undefined as well. So the line containing those 2 points has an undefined slope, which in turn means that you have a vertical line. And if you notice, if you drew a line between these 2 points, you would get a vertical line. So the slope of a vertical line is undefined. Find the slope of the line through the given points. So we look at the difference of the y's in the numerator over the difference of the x's in the denominator, and we have 0 over negative 7, which is 0. 0 divided by anything is 0. And like the previous example, if you drew a line between these 2 points, you would get a horizontal line. And there's your example of a horizontal line having a slope of 0, where the previous example was the vertical line having an undefined slope. So just to reiterate, the slope of a horizontal line is 0. All right, so here we're just finding the slope. I'm not sure why the book does this, since we know that when a line is in the form y equals mx plus b, the coefficient of the x is the slope. That's what the m is all about. So it seems really obvious that the slope is negative 4. You don't need any calculations, but they insist on finding 2 ordered pairs and using the slope formula. So if you want to do that, I guess you can, or you can just look at the equation in mx plus b form. Now here we're going to graph the line. So we know it goes through this one point, negative 1, 5, and we know what its slope is, negative 5 over 3. So what we're going to do is start at the point negative 1, 5, and then use our slope, the rise over run part. We're going to use that slope as directions to get us to another point. Now notice that slope, that negative, I can read that as down 5, negative 5, to the right 3, or I could read it as up 5 and to the left 3. That negative only goes on one of those numbers. Typically, it's the top one. So we start at negative 1, 5, and we count down 5. We count to the right 3, and there's our second point. Connect the dots, and there you have it. That's not necessarily something you're going to be tested over here, but it could be useful information. So that's all I have today. Go to MyOpenMath and do the set of problems that says 2.4 linear equations.